Let's go to LeetCode 3180. Maximum total rewards using operations. 1. For this question, it gives us the integer reward values. And we are trying to maximum the total rewards, but we need to follow this kind of rules. And for example, choose an unmarked index. That means if we choose a reward, we cannot use twice. And initially, we have an x value, which is 0. If we choose a reward, this kind of rewards I will add to our x. For the next round, we can choose those kind of value which should be greater than our current x. So ask what final maximal x we have. So we know for this question, the order matters. For example, if we select for example 1, right, we can select 1 and 3, right? But if we select 1, then our current x is 1, and we are able to select 3, right? So then x going to be 1 plus 3. So total will be 4, right? But if we select 3 first, our x becomes 3. Then we are not able to select 1 anymore. So we know this question, the first thing is the order matters. The second feature is that for a number, if it's already been selected, if there are duplicates, for example 1, 1, right? If we select that 1, then our current x will be 1, right? So the next value cannot be greater than current x. That means if there is duplicate, we can only select one of the number. Dupe, right? Just only one works. The third is that let's look at the data range, right? So you'll see the data, the rewards is 2000. So if we want to select 2000, this number, right? So the previous x can no bigger than 1999. So the final x, the largest possible possibility is 3999, right? So that means our total rewards will not be greater than 3999, right? So this is not possible. So this will be, looks like this kind of rewards have choice to select or not select. And we have capacity limitation that is 3999, right? So this looks like a traditional classical 0-1 backpack problem, right? For backpack, this one only have 2 dimensions. One is items, and another is capacity, right, or weight. So we can use a Boolean array, Boolean, for example, and n multiplied by 4000 the capacity, right, and dp to do this kind of problem. So we know for 0-1 backpack, it may have 3 some kind of other dimensions. For example, in capacity and some kind of numbers. And for each number, they may have some kind of profits, right? Let's ask the maximal profits. So those kind of will be some kind of 3-dimensional. We can use some kind of int number in the capacity weight, right? And for this one, we just want to see whether this weight is able to achieve or not. So we can use a Boolean, should be enough. So 3 things. One is the order matters. Another is it is a duplicate, right? Duplicate will not add to our results. Only distinct one works. The third is our capacity will not greater than 4000. So we know 0, 1 back problem. The order does not matter. Just a classical 0, 1 backpack. But for this one, the order matters. This matter is not because of 0, 1 backpack, but it's because the rule two that is reward value can only be added to X when those kind of X rewards I is greater than X, right? So this is another step for backpack is that when we want to add this item, we need to add another condition whether we are able to add this kind of value, right? So this sort is related to this, to whether we can add or not. Then let's write a two-dimensional DP first. Then let's after that we are going to convert to one-dimensional DP. So we know we need to sort the array. Then we have list of integer. Let's dedupe first. And list as that's not equal to this I minus one. Then we're going to add it, right? Then let's have int n equals list of size. And we're going to have write a two-dimensional DP first. One thing is that here, right? We sort then dedupe. Actually, if there are a lot of duplicates, we can do dedupe first, and we can use a set then sort, right? Let's write this better. So let's write two-dimensional array DP first. So new Boolean. Let's have n plus one items. We have an actual index so that we can set DP0 so that we don't need to worry about whether DP is 0 the first item, right? And we'll always let me see whether we need a actually have n should be enough, right? Let's have n, try to have n, and we know the weight And let's have for int I equals to 0, I smaller than 4000, I plus plus. And we'll have dp I 0 equals 2, right? That means for the weight 0, we are always to be achievable. And then let's write for int I equals to 1, I smaller than n, I plus plus. I should 0, right? Because the first item we should also be able to trying to see whether we'll add to our x. And I will say for int j equals to 0, j smaller than 4000, j plus plus. So we'll say the first dp ij, they should coming from the dp I minus 1 j, the previous round, right? So let's set one more index here. This is not 4000, this is n plus 1, right? Then let's put the one more index. And we are going to have a value equals list get I minus 1. Okay. So we'll say if j, this kind of weight is smaller to this value, right? It's smaller than this item, then this item are able to add to our j weight, right? So j is the x. Then we'll have dp I j plus value all equal to dp I minus 1 j, right? So this is our condition 2. In the end, we just need to try to see the for the dpn, right? The last item, and trying to iterate the weight from 4000 on 3999, trying to see the first Boolean value which is to be true. Then that is our maximum weight, right? So what we do is that for int I equal to 3999, I greater equal to 0, I minus minus. We can use j, right? Because we are always use j as weight. And if dpn j it should return j, and in the end to let it compile will return 0, right? Okay. Doing like this, the time complexity will be there is an n log n sorting. And also this is an n multiplied by the 4,000. So 4,000 multiplied by n plus n log n. Space is 4,000 multiplied by n, right? We know this is a classical backpack problem, but for backpack problem is that for every we can convert those kind of two-dimensional DP to one-dimensional DP, right? Because we'll see actually this kind of item we can reuse. The things that we'll see every DPIJ, it comes from two values. One is DPI minus 1J, right? Another is DPI minus I minus 1, right? J minus value. Coming these two kind of values, right? So when we convert to one-dimensional DP, the things that we need to iterate J from 3999 to smaller value, right? Because we are do a reverse if we don't ignore this kind of dimension, right? We want to reuse this to a DP. We need to use the previous round I minus 1 J minus value. So the second for loop, we should do a reverse traverse that will not be overwrite. So let's change this to two-dimensional DP. Okay, one-dimensional DP. So change this one to one-dimensional DP, right? We need to get rid of the n. And the good thing is that we can have DPI 0 to be true, right? And as we talk about for this one, we should equals 3999, and J should greater equal to 0, right? And we should have J minus 3. So this one we don't need to write again because it is just if we don't write, it is already coming from the previous round, right? And we should write this value is the least. Get this one, and we should also make sure this will not be out of range, right? Smaller than 4,000, right? And we don't need this. Okay. If you want to get your code looks neat, right? You can also dedupe at here, right? So, but that things that it will not be efficient as we dedupe here, right? Because we are handling us in a small subset, so this will be better. But if you don't want this kind of code, you can write something, for example, just arrays sort, arrays sort this one, and write if you don't want this, and write if item this kind of rewards I equals rewards I minus one continue, right? So, but since that this will handle this number of value, so that will not be efficient, then we dedupe here. We can also convert this to a Python. Now the time complexity does not change. This still in multiple by 4,000, but the space complexity is 4,000, right? Only 4,000 constant value. And we'll have dp equals false multiplied by 4,000, right? And the dp 0 equals to true. We need to have this kind of let's write the way which we dedupe in the for loop, right? And even this will be slower, but we can still get code simpler, right? So we just need arrays. How can we? Python is not array sort. It's just rewards values sort, right? And let's have n equals length. That's right. So what we do is that for I in range 1 to n plus 1, right? N minus 1, n plus 1. And for j in range 3999 minus 1, right? So we'll say if rewards value this kind of I minus 1, right? If this one is smaller equal to j, or if there is duplicate, or this one, I minus 1 actually equals to I minus 2, right? Because we have one more index, right? So we say I greater than 1 n, right? Then we are going to continue. So in this, we can do in this way to dedupe. And then we'll say if so now j is greater than this kind of rewards, right? J is smaller, right? J is x. So this means these rewards are able to add to our x. So but we need to make sure this j plus this one is smaller than our total, right? Smaller percent. Then we're going to have bpj plus rewards I minus 1. all equal to dpj, right? So so then we just iterate for j in range 3999 to -1 -1, right? If dpj return j, right? And in the end, just return 0. Then we can just as we mentioned, if we don't use a set to dedupe here, right? We can just in a for loop to dedupe. But this will not be efficient to use a set here, right? But the time complexity is still the same. dp Okay. So this is 1, right?